Good afternoon. I'm audible to everyone? So yeah, sorry for the bad fonts. It's not available on Windows systems on this. Okay, I hope you can still get what I'm trying to say. Okay, so the work that I'm presenting was presented at Reply this year. The work was done it is a joint work with the University of Pittsburgh, with Professor Diane Lippman and her postdoc Gary. So this collaboration involves certain difficulties, which I will let you know towards the end of the presentation, and which is it's not a difficulty that we brought upon ourselves. It is somewhat of a necessity in the context of MOOC data. Okay. Without further ado, let's go to the actual presentation. Okay, so to motivate the line of research that we are doing.
Sorry, I think the mic might not be on. Okay, try talking now.
Hello.
Okay, perfect.
This is CS203. This is a class that is taught by Damit and Yunjin, who presented yesterday. It has more than 260 students. This year, I hear there could be more than 300 students, and I'm one of the tutors for this particular class. So obviously, the instructor cannot focus or teach properly to all these people, right? Therefore, what we do is we divide the class into small groups, and those small groups are assigned tutors, and the tutorial goes on for the entire day. When the lecture is only on one day of the week. Okay. So during the tutorial, we are asked to encourage students to go look for information, search for. I mean, we are not supposed to teach them. That's the key point. We are not supposed to disseminate information during the tutorial. They have to go look for information, and we ask them to talk to their peers if they don't know, and try to get more information than they already know. Okay, and then during the second half of the class, they're supposed to engage in creating and building a software, which is not very intuitive. And this is one of the first software we plan to take. So the software that they're trying to build is actually quite large scale. Okay, so the part that the tutors do in the first half of the course is actually quite important. And I'm citing this as an example of instructor intervention. Okay. Now, in the context of MOOCs, right? Is it even possible to do something like this? How well? I mean, the only way to instructor for instructors to have a two-way conversation in an online learning setup, especially in MOOCs such as Coursera, where there is no co-location, is through discussion forums. In discussion forums, students have to interact with their peers as well as the instructor, whose time is heavily constrained through this only interface called discussion forum. Okay, at MOOC scale, instructors and TAs cannot even read every student's post. Okay, so and this is the scenario where only 5 to 10% of the students who are enrolled in a MOOC are actually participating in a discussion forum. And even at this scale, there are thousands of posts which nobody can even go through, let alone answering them. Okay. Now, currently, a lot of MOOC platforms exist. All of them offer, I think most of them offer a discussion forum. None of them are good enough for the instructor to go and interact. So there is just a Stack Overflow type forum, and people can post and people can reply to that. That's it. No automation, no pedagogical goals, nothing. Okay. So what is the need of that? We should try to improve this interface so that a two-way communication can happen, where some learning can actually take place. Something similar to what I talked about in the first slide can be done through an online setup. So we propose a solution where we try to build a system. We are not trying to replace instructors. Okay, that's the key point I want to make here. We are not trying to bring in bots and claim that bots can do what instructors are doing. We are trying to make the job of an instructor easier so that they can efficiently and effectively teach people in an online setup. So we want to design a ranking sort of a ranking system put in an information technical context. But the ranking is actually a form triage. Okay? That is going to rank the discussion forum threads in a way that maximizes learning as well as minimizes instructors' effort. Okay, and we acknowledge the fact that instructor cannot intervene on everything. They have a limited amount of bandwidth, and each instructor can have a different bandwidth. And depending on how much time they have, they are going to intervene. And we account for this by building this particular solution. Okay, so we proposed this particular system in EDM 2015. It was a very preliminary work, and we identified several challenges in doing them. And in this particular work, we are going to try and address one of those challenges. For this particular line of research, a few prior works exist, and we have strong systems on most of them. This was the first system that was built to predict instructor intervention on MOOC forums by folks at UMB. So they went for, they thought of this type of problem as a simple sequence stacking problem, and they evaluated on just two of the MOOCs, just two MOOCs, okay, and they claimed that their system was doing well, although their effort score was terrible, it was around like 29 points, and they claimed that this effort score is consistent, and you can deploy the system on any other MOOC and you will get the same performance. And both the MOOCs were on humanities courses. So our findings are very different. So when you actually try it on technical courses and as well as have different numbers of instructors, a lot of other stuff, you are going to know really terribly. And we try to replicate this experiment on our own crawled corpus MOOC data, and we are not able to do so. We are not able to replicate the performance at all. So another idea is to use topic models. Again, topic models are vocabulary dependent models. They also don't transfer well across courses. So this was our own work. So in order to address the challenges, we brought a much larger project in Coursera, 61 MOOCs. We couldn't replicate by ourselves. Performance does not scale with more training data. This I'm highlighting because this is a challenge that we are going to address in this particular video. Okay. Yeah, so this is also the scale at baseline that we are going to compare against in this particular work. Okay, so these are two example posts from one of the MOOCs that we analyzed. I'm not showing the entire post here at all. Okay, what you are seeing here are just what we call as discourse connectives. Are you okay? The font is a different manual, but can you say something about what's going on in this particular post? And the words are appearing in a sequential order. Okay, but the content words are removed. There is only discourse connectives here. So what we are claiming is that, so you can say that either the student is somewhat confused or is thinking through something just from the order in which the discourse connectives are appearing. So we are trying to we are going to try and make use of this particular intuition to extract features from discourse using a discourse parser, and then use them in our class. So this is actually the entire course. So we are going to throw away all this text inside function words that is here, and that's the key idea of it. Okay, the shallow discourse parser framework was originally proposed by Prasad et al. This is called the Penn discourse feedback. This is built from this was proposed for newswire data. Okay, and the first parser for this was actually built at our lab by a PhD student. And this is also one of the most popular parsers for this particular framework we made. So we are trying to show that use of this particular discourse connectives will provide domain independence for the prediction. So to explain a little bit about our corpus is also so the way we process the corpus is the same across all our works. We are only focusing on content related discussions in the MOOC. We are including general discussions and meetups and those types of discussions. And these 14 courses are from 2 different universities in the US and University of Pittsburgh. The reason that we are doing this is that we want to first of all show that this kind of experimentation can be done across 2 universities without actually sharing the data. The corpus is actually big enough, so the size of the corpus is similar to the one that we had used in our alien data, so that we are not evaluating our own claims. We are trying to use similar corpus size in this work as well. Okay, so we don't also do any annotation of intervention. Okay. So Coursera already marks threads that are replied by staff. We just treat them as interventions. Okay, but these are not actually true at all. Okay, a lot of these interventions could be where the community is and other people who don't know anything about pedagogy at all. So some of these could be very noisy, and there could be a lot of other interventions, a lot of other that are not intervening at all. Okay? Just keep that in mind when you are looking at the results. Okay? The setup is pretty nice. You just say all the intervening classes, intervening threads are positive instances. The rest of them are negative instances, which is also again not a very good assumption. We are trying to address that in one of our current works. Okay, so this to quickly describe our baseline. During in our alien study, we had proposed that the subform type under which a thread is posed determines the probability of its intervention highly. Okay. There are other this is what we call form type, and there are other nice features such as length of thread, blah, blah, blah. And many of these were proposed by the committee as a paper as well. So we try to replicate. We use some those features that actually work. Many of them did not work. The classifier, no deep learning yet, so you can relax on that front. Although I'm running some secret experiments that only many knows on deep learning, that's not public yet. So this is just a logical regression classifier. This classifier is suitable because this problem is very feature. You have a lot of features, you want to know what features work. So we just get a second for that a logical regression classifier. But there is a big class imbalance as you can know. And to address that, we use something called as class, which is again a very simple method. Okay, let me just, this is a core part of the method. So in order to extract discourse features, you need to run the PPTP discourse parser. So we treat each thread as a document, and every post in a thread as a paragraph. Okay. Then you run the discourse parser. Okay, so again, there are explicit connectives and implicit connectives. We are only extracting explicit connectives features because they are much more reliable to extract. And we only use the level 1 PPTP census because at a course grade level, it's much easier to, they are again much more reliable. Okay, so the parser shows 86% accuracy for categorizing census and explicit. So there is some error propagation, but we are just going to rely on them. We are not using the parser on new data at all because we need annotations. Again, we are issuing from any annotation-based methods. Okay, so these are our features. We use normalized counts of the 4 different census and the sequence of this census marker are also a set of features. In total, we have 25 features. Okay, just 20 features. This is something that is not there in our baseline. Our baseline has unigram, so we have hundreds and thousands of features. And it's interesting to see the performance of the classifier just 25 features. Okay. Again, we evaluate in 2 different setups, and we strongly recommend that every MOOC study that is empirical should adopt this type of evaluation. And in-domain evaluation within courses and out-of-domain evaluation that if they are taking generalization. Okay. Again, so the corpus size is another. Okay, so this side will let us know if there is any question why we have that question. Okay, so we see as minor improvement in the in-domain setting, right? 32.4, somewhat significant, whereas in the out-of-domain setting you see a larger increase. Okay, so the claim is that if you use domain-independent features, in an out of domain setting, you are going to have much larger training data, and you need to have domain independent features to actually leverage the larger training data. In our EDM paper, we have shown that no matter even if you have a course from 100 data from 100 courses, you are not able to predict with any certainty. So having larger training data does not work in this particular setting due to vocabulary, because the vocabulary across different MOOCs is very, very different. As different as classical MOOC versus nuclear science. Okay. And these are the detailed results. Just take a quick look at it to just see the variance in F1s. So I'm not going to go into the details of the performances. Okay, this is one question that I said I will address, right? So the last column is just PDB features, just 25 features versus EDM with thousands of features. You can see the gain in the PDB features, which is on an average around 11.6, okay, which is much more than. When I say gain, it is the gain between the in-domain setting and out-of-domain setting. So we see that the domain dependence that the features provide is very significant. Okay, some quantitative examples. So this type of there are still things that this method cannot capture. So in this particular example, student is proposing that some EpiPen auto injector is a very good thing that can be used, and the instructor intervenes and says, "Be very careful. This is not a very good idea." There are no discourse connectives in this particular example, and the only way for anybody to capture this intervention is by knowing the fact. Okay? There are a lot of interventions that require knowledge of facts, and these are very difficult to capture. Okay, something that we are currently working on is this. We have used explicit connectives. Now we are also trying to use implicit connectives. Implicit connectives are words that are not present in the post at all. Okay, so but the parser inserts them, and we find there is improvement by you try to use this at all. So this is a very preliminary result that I have, and this is not yet published. There is some improvement with respect to when you use implicit connectives. So interestingly, I'm thinking from Caroline's talk, this MOOC, accountable talk MOOC, has the highest improvement. Why? Perhaps it's because of transactivity. I didn't know about this. I mean, my collaborator carrying from I told that there is an instruction given to the students to practice transactive dialogue, and perhaps that is why this is better in this course. Okay, right. So the Codebase is on Github, and this is how we don't share data. So we share the code. I run the experiments on any data, and the carry runs the experiment over there, and then we aggregate the results. So we welcome anyone else who is having good data also to go and replicate the experiments. Let's see how well the results hold up. We are okay. We are perfectly okay to if you write up and say that we are not able to replicate your results. We are happy to hear such things. Okay. What are the future research directions? Okay. So another thing that we observe is that not all the negative instances are actually seen by the instructor, right? So it's not proper to use them as negative instances at all. If you have the view signal, then your prediction task and the effort score will be much different and better. So that's something we are working on. In the teacher roles, intervention by instructor versus intervention by TA. So that needs to be personalized. And then for ensuring the validity of our results, right? Yeah. So that is a research direction which that's a completely different research. I work with Kritika on that. We try to annotate some of the MOOC data, and by the time I present the thesis, I should be able to validate my models on the annotated data. The corpus is almost complete. We have around 1,200 threads. It's a very difficult annotation. It's again based on transactivity. We draw from the transactivity. Okay, So just to reiterate, conclusions are domain-driven features such as discourse connectives allow predictive models to leverage on the larger training data. Key points that we show in this particular paper. We better the state alarm network prediction. Perhaps the PDB features will work on other text-based problems also. So we look forward for the community to try out those. If you have any questions, please do.